right.
Somebody must have allergies stuff.
Well, the EMFs give me histamine response.
Oh my gosh.
So Wi-Fi,
I'm so sorry.
electricity, all the other, it's just cost of doing business.
Oh.
All right, so the first thing is you want to test your ohms. How much resistance between this appliance and the grounding conductor? Less than 1 ohms is confirming that this frame is...
Okay. So you always start out on ohms.
Yeah, start on ohms, and also it tests if your leads are attached correctly and everything's working right. Okay, the next thing is just flip it right over to voltage. And what this is going to be is just showing you literally what's the voltage between that appliance, and we have about 250 millivolts. Now the next thing is you're going to move it over to current, and then do it to MA. This is how many milliamps. So right now you have 4.4 milliamps of current on the frame of that.
Yeah, that's actually quite a bit, isn't it?
Yes. 2 microamps, which is 4 milliamps.
Yeah, be 4,000
is
microamps.
At least 2,000 times more than we want. We want 2 microamps or less. Milliamp is 1,000 times more than microamps. So we're talking about a health standard. Anything over 2 microamps is leukemia and cancer-causing environments according to EPRI. Now we have 4 milliamps. Anybody touching this surface and becoming grounded themselves allows this circuit to be completed.
Could they be grounded with their bare feet on the floor?
Now the next thing is to test how much would actually go through their body if they were barefoot to the floor. Now that's not the greatest thing. The greatest threat is a grounded outlet, grounded appliance to another grounded appliance. So what would be the nearest grounded appliance around here is the stove right underneath. So what we're going to do next is just connect these two points from here down to here. How much current will flow? It looks like it's on the same unit, so there's not going to be current flowing between them because it's the same unit. But let's go back to voltage. Let's see if there's a voltage difference. There shouldn't be any because it's the same point. Yeah, it's less than 1 volt. It's the same unit, so there's not going to be any voltage difference between that. So the only threat would be between touching the frame of this and any other grounded object. Now I'm just going to stick this onto the floor just for kicks. And we get 95 millivolts between the frame and the floor if you were in bare feet. And then I'm going to move this to current to see how much current would actually move. Do milliamps first. Doesn't look like we're going to get anything. Just a little flicker. So current will flow. I mean, 1 microamp, just a little bit between this floor, which is wood, you know, not much is going to flow, but you don't want any current.
Right.